One of the questions I get a lot is, why can't we create this diagram on a base 10 grid? What's this big deal about base 12? Are you sure we need to do it on a base 12 Cartesian plane? So my answer to that is actually quite simple, and it's because we want precise points to define the lengths of the lines and the lengths of the radiuses of the circles that we're drawing. So we are working in twelfths. We are working with lengths of 5/12, 7/12, that kind of thing. So in base 10, that is 5/12. So that's a fraction. We don't have access to the decimal place. So when we come to plotting those points on the Cartesian plane, just ask yourself, where is the point 1/3 on the x-axis? Where is the point 5/12 or 7/12? So when you go through the process of finding that specific point, you need to divide your 1 or your 5 or your 7 by 12. And as soon as you do that, you get a repeating decimal. So you don't have a precise point in twelfths. So it seems like it's really close. You go, well, it's just twelfths. It's like it seems accessible. You can write it as a fraction, and you're looking at it and you think, yeah, here, like it's right here. I have this length of 1, and these shorter lengths are twelfths. There's 12 lengths. So the tenths are larger. But then you think, okay, well, I mean, it's all right there. Why can't we just say it's twelfths and leave it at that? But the structure of this pattern is attached to those points. And we start off with it just seems like a simple grid, but then we go into the grid and we go into those twelfths become 1/44, and then, deeper and deeper and larger. And the structure of the grid is easy to create, and then it's easy to find those points. But when you as soon as you convert to base 10 to do some trigonometry perhaps, or to do a calculation that's already been made, all those tables of numbers that we've created already in base 10, as soon as we do that division equation and get that repeating decimal, we lose that precision. You think, okay, well, where is 1/3 on the Cartesian plane between 0 and 1? Where's that point? And it doesn't exist. We divide, and it's that step of dividing. You can't just say, well, it's easy to find 1/3 on here. If we start up here on the base 12 side, we go 1, 2, 3, 4. It's right there. 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 4s in base 12, those are thirds. 0.4 is the answer to what's 1 divided by 3 in base 12. But, 1, 2, 3, so right there. But we know in base 10, it's 3.3. We have to divide this by 3. It's the fact that you